All right, so for this formula, we're going to learn how to give drug infusions. And this formula is a little different than the one that we were using for our other drip rates because we're not trying to give a certain amount of fluid over time. We're trying to deliver a certain amount of drug, which would be our desired dose, and a certain amount per minute from a different concentration. So it depends how the drug was mixed. So we're going to use the formula dose ordered times drip factor over concentration. And I would abbreviate that just by doing DO times DF, and then I abbreviate concentration by just putting a C. So we'll see that formula be written out with some of the practice problems. So we mainly use this for dopamine. So we're going to first look at dopamine. That's the main drug that we'll be using this formula for. Dopamine is typically already pre-mixed in a bag for us, and it comes in a concentration of 400 milligrams in 250 mLs of D5W. So since it's already pre-mixed, it's not something that we have to make like our epi drips. There are some things we need to remember about dopamine. First of all, we're always going to use microtubing when delivering an IV drug infusion. So this gives us a little more control over our flow rate, and it makes it a little easier to count out our drips. So whenever we're putting drip factor into our equation, it's always going to be 60 drops per ml, and that is our microtubing. Our dose of dopamine is 2 to 20 micrograms per kilogram per minute, and our practice problems will give you how many micrograms per kilogram per minute we want you to administer. Just remember, in real practice, we commonly use 5 to 20 micrograms per kilogram per minute because that 2 to 5 micrograms per kilogram per minute really only has certain effects that kind of open up and dilate the renal arteries. So it's used in the hospital sometimes for acute kidney failure, but it has no use in pre-hospital EMS. So we typically start at 5 micrograms per kilogram per minute. But again, we'll give you what dose we want you to have in the problem. The last is figuring out our concentration. I apologize for that. The mailman came, so my dogs felt the need to bark. So we need to figure out the concentration of dopamine. Our dose is in micrograms, which means I need to change my concentration to micrograms to use it in the same formula. We want our units to match when we're using it in the same formula. So to convert this dose into micrograms, I needed to figure out the concentration in micrograms. So I was given 400 milligrams in 250 mLs of D5W. So I put 400 over 250. My next step, I needed to change that milligrams to micrograms. So remember back to 131 when we were going over math conversions and we had that chart. That chart looked something a little bit like this. We had grams, this way we had kilograms, this way we had milligrams, this way we had micrograms, and we were going to move that decimal point. So if I wanted to go from milligrams to micrograms, I would move that decimal point 3 places over to the right. So that's what I did here. So 400 milligrams is equal to 400,000 micrograms. So I put 400,000 over 250 mLs, and I ran out of room, so I put it down here. I did cancel out my zeros to make my math a little bit easier, and I had ended up with what would have been 40,000 over 25. So I went ahead and did that long division already, and I got 1,600. So my concentration of dopamine is going to be 1,600 micrograms per ml. Now, we've already figured that out. Dopamine comes the same way every single time. So you only have to figure out this concentration once. So what you're going to do is you are just going to memorize that 1,600 micrograms per ml is the concentration of dopamine. It is always going to be 1,600 micrograms per ml. So if we look at the way we're going to set up our formula, our dose ordered is the one thing that we will have to figure out, our desired dose times weight in kilograms. Our drip factor is always going to be 60 because we're always going to use microtubing. And our concentration for dopamine is always going to be 1,600. It's always 1,600 micrograms per ml. So we do not need to fill out or figure out this anymore. So let's look at our first problem. We're ordered to administer dopamine at 5 micrograms per kilogram per minute. Patient weighs 80 kilograms. Our dopamine is supplied at 400 milligrams and 250 mLs of D5W. This part to me, I don't even need it in the problem because I already know that my concentration of dopamine is going to be 1600 micrograms per ml. How many drops per minute will I administer if I use micro drip set tubing? So I'm going to write out my formula. Dose ordered times drip factor over concentration. My dose ordered is the only part that I don't have given to me. I have 5 micrograms per kilogram per minute is my desired dose. My patient weighs 80 kilograms. So to figure out my dose ordered, I'm going to do 5 micrograms times 80 kilograms. So my dose ordered is going to be 5 times 80. Let's go ahead and figure that out. Oop. Just totally set that up backwards. All right. 80 times 5. 5 times 0 is 0. 5 times 8 is 40. So my dose ordered equals 400 micrograms. My drip factor, I'm always going to use that micro tubing. That's 60 drops per ml. And my concentration, I've already figured out above, and it's always going to be 1600 micrograms per ml. So now I'm just going to plug these numbers into my equation. So dose ordered, I have 400. Drip factor, I have 60. My concentration, I have 1600. Let's go ahead and get rid of some zeros here. I have a 0 on the end there, 0 on the end there. Same with here and here. So now I have 40 times 6 divided by 16. Let's go ahead and do 40 times 6. 6 times 0 is 0. 6 times 4 is 24. So I have 240 divided by 16. Sixteen goes into 24 one time. I have 8 left over. 16 into 80. We're going to have to do some guessing. So let's figure out what 16 times 4 is. 16 times 4 is 24, or 6 times 4 is 24. 4 times 1 is 4 is 64, so it's going to be a little bit more than that. Let's do 16 times 5. It's 30. 5 times 5 plus 3 is 80, so it equals 5 exactly. And I have no remainder, so I can stop right there. So I'm going to give this patient 15 drops per minute. And that would be my answer. All right, let's look at the second one. I'm ordered to administer dopamine at 10 micrograms per kilogram per minute. Patient weighs 43 kilograms. Dopamine supplied as 400 milligrams and 250 ml. I don't need that part of the problem. Just ignore it. I already know what my concentration is. And I'm going to use micro drip set tubing. So let's go ahead and write out our equation. We have dose ordered times drip factor over concentration. My dose ordered is going to be, I want 10 micrograms per kilogram per minute. I have 43 kilograms. So it's going to be 10 micrograms times 40 kilograms. So 10 times 40. It's pretty easy. It's going to be 430. Oops. It's supposed to be 43 kilograms, sorry. So 10 micrograms times 43 kilograms. So I want to get 430 micrograms. My drip factor, always going to be 60. My concentration, always going to be 1600. This is drops per ml. This is micrograms per ml. So let's go ahead and plug these numbers into our equation. I've got 430 times 60 over 1600. I'm just taking these numbers and putting it in this equation. I have some zeros on the end here, so if I take a 0 off top, I gotta take a 0 off bottom. So I have 43 times 6 over 16. So let's just do the 43 times 6. 6 times 3 is 18. 6 times 4 is 24, 25. So I've got 258 over 16. Sorry about that. So 16 into 258. 16 goes into 25 once. 15 minus 6 is 9. Leaves me with 98. So I already know that I did up here, 16 times 5 is 80. So I'm going to go 16 times 6. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. It gives me a remainder. Remember, with our drips, we do need to find a 1 decimal place so we can round to the nearest whole number. This one's pretty easy. It only goes in once. You can stop after getting 1 decimal place because we're going to round to the nearest whole number. So for this patient, I'm going to give 16 drops per minute. Make sure you write out your answer. And circle it so we can find it. All right, moving on to our next one. We're ordered to give dopamine at 12 microgram per kilogram per minute. Patient weighs 94 kilograms. Our dopamine supplied in 400 milligrams and 250 ml. I've already figured that out, so I can just ignore that part of the problem. And we're going to use micro drip set tubing. So my equation, dose ordered times drip factor over concentration. My dose ordered, I want 12 micrograms times 94 kilograms. My drip factor is always going to be 60. My concentration always going to be 1600. So my first part of my math here is I need to figure out 12 times 94. 4 times 2 is 8. 9 times 2 is 18. Make sure you put your placeholder 0. 1 times 4 is 4. 1 times 9 is 9. So 8 plus 0, 8. 8 plus 4, 12, 10, 11. So my dose ordered is going to be 1,128 micrograms. So now I'm just going to plug all these numbers into my equation. I have a 0 on the end, a 0 on the end. Unfortunately, I don't have any more zeros, so I have to leave it there. So the first part we're going to do is this 1,128 times 6. 6 times 8 is 48. 6 times 2 is 12, plus 4 is 16. 6 times 1 is 6, plus 1 is 7. And 6 times 1 is 6. So I have 6,768 over 160. So this one's going to be a little bit more difficult. All right, so I don't know my times tables by sixes, so it's okay to start kind of guessing a little bit and just kind of play around with some numbers. Let's go ahead and try to do 676 times, or 160 times 5, and see where that gets us. So I need to figure out how many times 160 goes into 676. So 5 times 0 is 0, 5 times 6 is 30, 5 times that's 800, so that's not going to work. Let's try 160 times 4. 4 times 0 is 0, 4 times 6 is 24, 4 times 1 is 4, 5, 6, that will work. So 160 goes into 676 4 times. 6 minus 0 is 6, 7 minus 4 is 3, then we have nothing there, so we can go ahead and bring that down. All right, how many times does 160 go into 362? Well, I know that 16 times 2 is 32, so 160 times 2 is going to be 320. So that one is a little bit easier. And that leaves us with a remainder of 48. So we do have to go ahead and find that one decimal place. How many times does 160 go into 480? Well, I know that times 4 is 640, so let's try times 3. See what we get. 3 times 0 is 0. 3 times 6 is 18. Carry over the 1. 3. Oh, that actually works out perfectly. So I need to round this to the nearest whole number because we're giving drips and we can't give a fraction of a drop. So I'm going to give this patient 42 drops per minute. So that one was slightly more complicated just because we couldn't get rid of a lot of zeros there. So we had to divide 160 into a number, which always makes it a little harder. All right, let's take a look at number 4. So still dopamine. I want to give 6 micrograms per kilogram per minute. My patient weighs 175 pounds. My dopamine supplied in 400 milligrams and 250 ml. I don't really need that part. I know that my concentration is 1600 micrograms per ml. It always is with dopamine, and I'm still going to use a micro drip set tubing. So the first thing I need to do in this problem is I need to change this pounds to kilograms because my dose is in kilograms. It's weight per kilograms. So I need to be able to figure out my desired dose, and I can't do that with pounds. So this is why we make you do this in 131. So I'm going to take, remember your pounds or your kilograms is your pounds divided by 2.2. To make things a little easier, we move that decimal place over 1, which means we need to move this decimal place over 1. So that gives me 22 into 1,750. So I need to know how many times 22 goes into 175. Well, I know that 20 goes into 180 9 times because 2 times 9 is 18. So I can try out one less than that. I'll try 8. 8 times 2 is 16. 16, 17. So that's going to put me 1 too many. So it's going to have to be one less than that. It's going to be 7. 2 times 7 is 14. 2 times 7 is 14 plus 1 gives me 154. All right, so I need to know how many times 22 goes into 210. The easy thing about this one is I know that 22 times 10 would be 220, so it's going to be one less than that at 9. 22 times 9. 9 times 2 is 18. Sorry about that. We turn that off. And then 9 times 2 is 18 plus 1, so I get 198. So I get a remainder of 12. So we need to add our decimal. Bring down another 0. 22 goes into 120. It's going to be 5 times, which gives me 110. Now, I am okay with you stopping here for your kilograms because when we're putting this into a formula, I know that we normally make you find kilograms to the nearest tenth, which means I would technically need to find out one more decimal place. However, since we're putting this in a formula, I'm okay with when we're doing dopamine math if you round your kilograms to the nearest whole number, because really, once you do all the math, you're going to get the same answer. So we can just go ahead and round this to the nearest whole number and we'll get 80. 79.5 will round that up to 80 kilograms. So I still have dose ordered times drip factor over concentration. My dose ordered, I want 6 micrograms per kilogram. And I have 80 kilograms. My drip factor is still going to be 60. My concentration is going to be 1600. So now I just need to find that 6 micrograms times 80 kilograms to get my dose ordered, my desired dose. course, and then I set it up backwards. 80 times 6. I've got 6 times 0, 0. 6 times 8 is 48. So my dose ordered for this patient is going to equal 480 micrograms. So now I can go ahead and set up my equation. But that first part, you need to pay attention in your problems. Is it giving you pounds or kilograms? So like for this one and the next one, we had to convert that pounds into kilograms before we could do our dopamine math. So I've got 480 times 60 over 1600, 0, 0, 0, 0. So I got 48 times 6 over 16. 6 times 8 is 48. 6 times 4 is 24. Plus 4 is 28. So I've got 288 over 16. Sixteen goes into 28 once. 8 minus 6 is 2. 2 minus 1. All right, so now I need to find 16 into 128. So this is again where we just kind of start to do a little bit of guessing. So we already did like 16 times 5 was 80. So 16 times 6 is 96. So let's try 16 times 7 would still be less than 128 because 96 plus 16. So let's try 8. And again, you might have to write out some of these problems to figure out which one it is. 6 times 8, 48. 8 times 1 is 8 plus 4. Well, that worked out perfectly. So I can stop right there because I don't have a remainder. So for this patient, I'm going to give 18 drops per minute. And that gives me my desired dose of 6 micrograms per kilogram per minute. All right, last one for dopamine. We're ordered to administer dopamine at 15 micrograms per kilogram per minute. Patient weighs 80 pounds. So again, we have to convert that pounds to kilograms. Dopamine supplied in 400 milligrams and 250 mLs. We don't really care about that part because we've already figured that out. And we're going to memorize that dopamine always has a concentration of 1600 micrograms per ml. And we're always going to use microtubing. So first, let's convert that 80 pounds into kilograms. So we need to divide 80 by 2.2. Remember, we're going to move that decimal place over, which means we need to move it over here. And that gives us 22 into 800. So 22 goes into 80 3 times. Gives us 66. $22 goes into 140. Well, I know 20 goes into 147 times because 2 times 7 is 14. So 20 times 7 would be 140. So it's probably going to be 1 less than that. So I'm going to go with 6. And that does give me 132. So I've got a little bit of a remainder here. 22 goes into 80. We already figured that out 3 times. You can see there's a bit of a pattern here. So now because we are doing dopamine math, I'm fine with you rounding that kilogram to the nearest whole number. If we were just converting into kilograms and I wanted you to tell me how many kilograms 80 pounds was, I would expect you to put 36.4 because we want you to find the nearest tenth. But because we're putting this into another formula, I'm fine with you rounding to the nearest whole number because actually you'll get the same answer in the end. So we're going to round this to 36 kilograms. So our dose ordered is going to be, we want to give 15 micrograms per minute, per kilogram, sorry. Oops, and then I was going to put 80 pounds. And we have 36 kilograms. Trip factor, always going to be 60, and our concentration is always 1600 micrograms per ml. All right, so we need to figure out what 15 times 36 is. 6 times 5 is 30. 5 times 3 is 15 plus 3, 18. 1 times 6 is 6. 1 times 3 is 3. So I have my columns, which you know they're not completely straight. 8 times 6, or 8 plus 6 is 14. 3, 4, 5. So my dose ordered is 540 micrograms per minute. Now I'm just going to plug these numbers into my equation. I'm able to get rid of a few zeros here. Got 0 on the n, 0 on the n. So I have 54 times 6 divided by 16. So let's figure out what 54 times 6 is. 6 times 4, 24. 6 times 5 is 30 plus 2. We have 32. So that gives me 324 divided by 16. 16 goes into 32 twice. That was nice and easy. It equals 32. 16 goes into 4 0 times. So we need to add a decimal here. 16 goes into 40 2 times, which is going to be 32. Now we can go ahead and stop right here because remember I'm going to round to the nearest whole number, so I only need to find one decimal place. And this is going to end up being 20 drops per minute. So I'm going to round that 20.2 to 20. Make sure you circle your answer so we can find it. So in order to get 15 micrograms per kilogram per minute, my patient weighs 36 kilograms. I'm going to deliver 20 drops per minute to get that desired dose. All right, let's move down to epinephrine. So epinephrine is not premixed for us. It is a good alternative to dopamine, but if we do carry dopamine, we would rather give that dopamine. And if you remember back to the drug review lecture in 132, I kind of explained how dopamine ups that systemic vascular resistance. And what that means is it causes more vasoconstriction, but it's more vasoconstriction in the periphery and not the core. So it's shunting more blood to our vital organs in our core without having to raise the heart rate as much, or, it's going to help raise the blood pressure, but it's a better way of doing it than epi does. Epi does not have the same effect on our systemic vascular resistance. Epi works more to increase the conduction through our conduction system in our heart and kind of make that heart contract harder. Dopamine does those same things, but it has more effect on the vascular resistance than epi does. So we can use epi as an alternative. For example, where I currently work, we actually don't carry dopamine. We only use epi. And there are a few different ways to mix it. So a lot of people are kind of intimidated by this medication because it doesn't come pre-mixed. The way we mix epinephrine is we're going to take 1 milligram of epi and we're going to put that 1 milligram in either a 100 ml, 250 ml, 500 ml, or 1 liter bag. Really, whatever we have available to use for our patient to mix this, we can use. And I will show you kind of all the different concentrations that we would make. The smallest volume bag we can use is going to give us a more controlled dose. So if we have a 100 ml bag available, that would be something that we would choose to use. Where I work, we only carry one 100 ml bag. So I would be a little concerned using that for my epi drip because I need it for my amiodarone drip if I were going to need to use that. We may have a 250 ml bag or a 500 ml bag. It just kind of depends on if the hospital had that in their stocking or not. But many times we actually end up using a 1 liter bag for this. To mix that's supposed to say to mix the medication, we're going to drop 1 ml of fluid out of that bag, the saline bag. whichever, if we're using D5W or normal saline, we're going to draw 1 ml out of that medication port, and we're going to put in 1 ml of epinephrine, which is 1 milligram of your epi 1 to 1,000. So we're taking out 1 ml of fluid and we're replacing that with 1 ml of epinephrine, or 1 to 1,000 concentration. So we're putting in 1 milligram. Those bags are volume controlled. So if we try to put in more fluid than there's allowed room for, it'll actually push an ml of fluid out of the bag. So we want to take out any fluid we're putting in, we want to take out prior to, and we're kind of just replacing the volume, almost like drawing out of a multi-dose vial. If you don't have your 1 to 1,000 able to mix, like if you only carry EpiPens, you can use your 1 in 10,000. You would just draw out 10 mLs of fluid from that bag and replace that with 1 milligram of your Epi 1 in 10,000, which is 10 mLs, that whole amp. So whatever size bag we're using, we're going to draw out 1 ml of fluid and put in 1 milligram of epinephrine. If we're going to 1 to 1,000. If we're going to use 1 in 10,000, which is not, it's easier just to use the 1 in 1,000. You need to draw out 10 mLs of fluid, and then you can put in the 1 milligram of epi of your 1 in 10,000. When you do mix this, don't shake the bag after you mix it. It just causes a lot of bubbles, and then those bubbles will get in your drip set, and then you have the risk of bubbles going into your patient. So just roll it around gently. It doesn't take a whole lot to mix this together, so just rolling it around gently for a couple seconds will mix that well enough. In your protocol, you'll see that the dose of epinephrine is weight-based. However, the more common dose for epinephrine, and you'll see this in a lot of drug dictionaries, is 2 to 10 micrograms per minute. So that is not a weight-based dose. And if you sat there and took everyone's weight and put it into that weight-based dose, you're going to end up somewhere in the range of 2 to 10 micrograms per minute. So I recommend, and we're going to practice using just the dose of 2 to 10 micrograms per minute. It's a lot easier. If you would like to use the weight-based dose, you would do it very similar to how you set up your dopamine, and that's fine, but it's going to cause you a lot more work. So we're going to do 2 to 10 micrograms per minute, and that's a range. So what we want to do is we want to kind of find out that range. How many drops per minute is 2 micrograms per minute? How many drops per minute is 10 micrograms per minute? That way we know where to start, and we know how much we can titrate up that dose to get our desired effect, and when we need to stop, when we've maxed out. The concentration is going to depend on what size bag we use. So our concentration for all these epi problems are going to be a little bit different. We do want to use micro drip set tubing for all of these. However, once you start getting into the liter bag size, you'll see that it's 600 drops per minute. That's not something we can really do. So once you get to a liter size bag, you may want to use your macro drip set tubing, and we're going to work out that problem at the end here. So let's go ahead and just dive right in, and we're going to start looking at these questions. So we're ordered to give epinephrine and epi drip at 2 to 10 micrograms per minute IV, and we're going to use a 100 ml bag of D5W to mix my infusion. So I'm going to take a 100 ml bag, I'm going to draw out 1 ml of that fluid, I'm going to waste it, and I'm going to put in that medication port 1 ml, which is 1 milligram, of my 1 to 10,000 1 to 1,000 epinephrine. And then I will get my mixed infusion. My patient weighs 96 pounds. That doesn't matter. That's extra information. This is not weight-based dose. And I have micro drip set tubing. So it's just something I want to keep in mind. So first of all, let's figure out our concentration. I've put 1 milligram of epi into 100 mLs of D5W. So I have 1 milligram in 100 mLs. My dose is in micrograms, so I need to change that 1 milligram into micrograms. So remember, we did this up top earlier. To get from milligrams to micrograms, I need to move that decimal place over 3 spots. So 1 milligram is equal to 1,000 micrograms in 100 mLs. I can definitely simplify this, get rid of my zeros. So I have 10 micrograms per ml. So my concentration is 10. My dose ordered, we need to figure out 2 because we have 2 to 10 micrograms per minute. My drip factor equals 60. So let's go ahead and just figure it out for the first one for 2. I have dose ordered times drip factor over concentration. So my dose ordered, I have 2, because I'm going to figure out the smallest part of my range, times my drip factor, which is 60, divided by my concentration, which is 10. 2 times 60 equals 120, divided by 10. We can simplify. So I get 12 drops per minute. Now let's figure out the higher end of my dose. We're going to do 10 micrograms per minute. Still using the same formula. My dose ordered though is going to be 10. Drip factor, still 60. Concentration, still going to be 10. So 10 times 60. Oh, we can actually reduce here. I have 10 times 6 over 1 equals 60 over 1. So I'm going to give 60 drops per minute. So that's 1 drop every second. So for this patient, if I'm mixing this this epinephrine infusion into a 100 ml bag of D5W or saline, it doesn't matter, I'm going to give 12 to 60 drops per minute, which means I'm going to start at 12 drops per minute, which is 1 drop every 5 seconds. 60 seconds divided by 12 is 5. So I'm going to start at that low end. I'm going to watch my patient. Things I'm going to look for is my blood pressure increasing, is my heart rate increasing, is my mental status improving, is my patient's skin pinking up, are they coming around? And I can titrate that 12 drops per minute up to 60 drops per minute to get that desired effect of all those things that I want to see in my patient. All right, let's look at the next one. We're going to do the same thing. EpiDrip, 2 to 10 micrograms per minute. This time we have a 250 ml bag of NS, of normal saline, to mix our infusion. So I'm going to take that 250 ml bag of normal saline. I'm going to draw out 1 milliliter. I'm going to waste it. And I'm going to put in there 1 milliliter of Epi 1 in 1,000, which is 1 milligram. And that's going to give me 1 milligram in 250 mLs. Now remember, we need to change this milligram to microgram to figure out our concentration. That's what we're doing here. So 1 milligram is 1,000 micrograms, just like we figured out before, over 250 mLs. Take off some zeros, so I have 100 micrograms over 25 mLs, 100 divided by 25. You got 4 quarters and $1. So you're going to get 4 micrograms per ml. So dose ordered, remember we want to find out a range. Drip factor, always going to be 60. My concentration, figured out here, is going to be 4 micrograms per ml. Same formula we've been using for all of these drug infusions. Doesn't change. So let's go ahead and figure out the low end first. So we're going to start with the 2 micrograms per minute. So my dose ordered is just 2 micrograms per minute. It's not weight-based. Times my drip factor, which is 60, and over 4 because my new concentration is 4. 2 times 60 is 120 divided by 4. And 120 divided by 4 is 30. 30 drops per minute. Now let's figure out the higher end. We're going to do my 10. 10 for my dose ordered, 60 for my drip factor, for 4. That gives me 600 divided by 4. So I may need to figure this one out. We'll go up here, we have some room. How many times does 4 go into 600? I have 4 goes into 60. 4 goes into 6. Wow, had a mental block there. 4 goes into 6 one time. Gives me 2. 4 goes into 25 times. Equals 20. I got 0. I got 0 left over here. So 150. So for this patient, I'm going to give 30 to 150 drops per minute. So you can see once we start to get to these bigger numbers, that's where you may want to consider starting to switch to your macro tubing. We're going to do that on the last problem, so I'll show you what I mean on the last problem there. Of course, we're going to want to circle that. All right, we're going to do an epi drip 2 to 10 micrograms per minute IV. This time we have a 500 ml bag that we're mixing our 1 milligram of epi in. So to figure out my concentration, I have 1 milligram of epi and 500 mLs. I already figured out 1 milligram is equal to 1,000 micrograms. I have to switch it to micrograms because my dose is in micrograms. So they need to be the same. So I have 1,000 and 500. Get rid of some zeros. I have 10 and 5, which equals, if I divided 10 by 5, 2, 5 and 1 is 5. So I have 2 micrograms per ml. Dose ordered, I have a range, 2 to 10. Drip factor, we're going to stick with 60 for now. This is where I could start moving up into maybe some macro tubing though. And we would give you the tubing size in the problem if we were to give you an epi problem, so don't worry about having to figure out the tubing size. Oops, that was supposed to be a C. My concentration, 2 micrograms per ml. Now I'll just plug these into my equation, dose order times drip factor over concentration. My dose order, I'm going to start at the low end, 2, drip factor 60, concentration is 2. So really here, we could just cancel out these 2's. What we take off the top, we take off the bottom. Or you could do 60 times 2 is 120, divided by 2 is 60. But either way, we're going to get 60 drops per minute. So let's go ahead and figure out the higher end. My dose order now is 10. Drip factor 60, divided by 2. 10 times 60 is 600, divided by 2. It's going to be 300 drops per minute. Pretty much for that patient, if we're using that microtubing, we're just going to run it wide open. We're going to start with 1 drop every second, and then we could titrate that up to pretty much wide open. So this is actually my preferred method of giving epinephrine infusions. If I have a 500 ml bag, I like using the 500 in my microset tubing because realistically, I know that I can start that at 1 drop per second, which is pretty easy to count out. And then I could titrate that up to wide open if I needed to get my desired effect. So it's not an exact science, but it's applicable to treat your patient. So here I'm going to have 60 to 300 drops per minute. And if we were to give you a problem like this on a math test, we might say, hey, find it for 4 micrograms per minute or find it for 2 micrograms per minute. We might not make you find the range. I just wanted to show you how to find your high end and your low end so you kind of knew where you needed to put that drip. All right, next one. Now we're mixing our epi in 1 liter. So still have 1 milligram of epi. This time I'm just putting it in a 1 liter bag, which is 1,000 mLs. And a lot of times this is what we kind of end up doing because the liter bags are the most common that we have. So this is actually kind of common, although it's not like the most preferred way, and you'll see why when we get our drops per minute. So 1 milligram, I need to change that to micrograms. Oh, and there's a typo in here. It's not supposed to be per kilogram per minute. So we'll take that out. It's just supposed to be 2 to 10 micrograms per minute. So 1 milligram over 1,000 mLs. I have 1,000 micrograms, because that's equal to 1 milligram over 1,000 mLs. So really this concentration is going to be 1 to 1. So it is the easiest one to figure out. Dose ordered, we have 2 to 10. Drip factor, we're going to use micro for this one. We'll use macro down here. And our concentration is 1. So let's go ahead and plug this into our equation. Dose order times drip factor over concentration. Let's start with our low end. Dose order is going to be 2. Drip factor is going to be 60. Concentration is 1. So you get 120 over 1. It's 120 drops per minute. And I'll fix this typo before I upload it to Canvas for you guys. Let's go ahead and do our higher end. I have 10 as my dose ordered micrograms per minute times 60 over 1. So you can see how this would be pretty hard to control on your dose and how many drops per minute you're giving, because you can't realistically do 600 drops per minute. Because for this patient, we're going to have this range. I have seen people do this with microtubing and just run it wide open, and it does still help your patient because you are wide open. You're getting actually, more than your 120 to, it's going to fall within that range of 120 to 600. But if I'm going to use a liter bag, I might actually prefer to go ahead and use, and here's another typo, I put kilogram again. I'll take those out before I post it to Canvas. I would actually, if I'm going to use a liter bag, I'd probably go and start using my macro set tubing, just because I cannot control 100 to 600 drops per minute. So let's go down here and we're going to figure out the same problem, but we're going to use a different type of tubing. Excuse me. So this time we have the same thing. We have 2 to 10 micrograms per minute. We have a 1 liter bag, just like our prior problem. It doesn't matter how much the patient weighs. That was just extra information. Sometimes it's just thrown in there, and just ignore it. It's just there to throw you off. So just cross it out. But this time we're going to use macro tubing. That's 10 drops per ml. So we've already figured out that concentration. The 1 milligram in 1 liter is 1,000 micrograms in 1,000 mLs. We do have to change that liter to ml because our drip set's in ml, and remember we want all those units to match, and that gives us our concentration of 1 in 1. Dose ordered still the same, 2 to 10 micrograms per minute. The only thing changing here is our drip factor. We're going to change it to 10. Same formula, dose order times drip factor over concentration. We'll start at the low end. My dose ordered is 2. My drip factor here is different. It's going to be 10. And my concentration is 1. 2 times 10 is 20 over 1. So that's going to be 20 drops per minute. So you can see how that would be a lot easier to control if we're going to use that liter bag. It just gets too much when we're using a large amount of fluid to use that micro set tubing. Let's go ahead and figure it out for our top one here. So my dose ordered is 10 times my drip factor is now 10 over 1. 10 times 10 is 100. So we can see how that changes. A lot easier to control that 20 to 100 drops per minute when we use that liter bag. So if we do give you an epi question, like I said, we'll give you the whether we're going to use micro, what you can assume is 60, and if it's macro, we'll give you how many drops per ml it is. But just for your practice, keep in mind that if you are going to use that liter bag, you may want to switch to that macro tubing. All right, we can use this formula in application to other medications, some lesser common medications that we give. But I just want you to be able to use it. You can use this with any medication as long as you figure out the concentration. This was supposed to be 2, so that'll be changed on your Canvas one. So we're going to do lidocaine. We need to administer 2 milligrams of lidocaine per minute. And this is you're probably not gonna use this in your practice because we don't really use lidocaine anymore. We use amiodarone instead. But I just wanted to show you that we can really use this for any medication as long as we can figure out the concentration. So we want to give lidocaine drip. And this would be if we had a patient in a VFib arrest and maybe we gave them lidocaine and we got ROSC and we want to give them a lidocaine follow-up drip to make sure they don't go back into that VFib or VTEC. So our desired dose, our dose ordered, is 2 milligrams per minute. It's pretty easy. It's not weight-based. So dose ordered, 2 milligrams per minute. It's easy. Patient weighs 136 pounds. Extra information, it's not weight-based. We can ignore it. Lidocaine comes pre-mixed in a bag with 2 grams of lidocaine and 500 mLs. So our concentration, we have 2 grams in 500 mLs. So we will need to figure out that concentration. 2 grams. If I wanted to change grams or doses in milligrams, so I need to get it to milligrams. So if I'm going grams to milligrams, I'm going to move that over 3 spots. So it's going to equal 2,000 milligrams, 500 mLs. Get rid of some zeros. I have 20 milligrams in 5 mLs. 20 divided by 5 is 4. So my concentration is going to be 4 milligrams for 1 ml. So really the biggest part of these problems is figuring out the concentration. My drip factor is microtubing. So it's going to equal 60. So now I'm just going to plug these numbers into my equation up here. Dose ordered, 2. Drip factor, 60. Concentration, 4. 2 times 60, 120, divided by 4. 12 divided by 4 is 3, so 120 divided by 4 is going to equal 30. So I'm going to give 30 drops per minute for that patient. And last one down here. This one's a little more tough. We're going to give amiodarone. My desired dose is going to be 1 milligram per minute. So that sounds pretty easy. Patient weighs 304 pounds. Well, my dose isn't weight-based, so I don't care. We're going to cross that out. The amiodarone comes pre-mixed as 900 milligrams and 500 mLs of D5W, so we need to figure out that concentration. Luckily, this is in milligrams, and my dose is in milligrams, so I don't need to change any units. I've got 900 milligrams and 500 mLs. We can get rid of some stuff, so I got 9 and 5. How many times does 5 go into 9? Once. Gives us 4 left over, so we do need to add a decimal. 5 goes into 40, 8 times, which equals 40, so we can stop right there. So my concentration is going to equal 1.8. So, dose ordered. I want 1 milligram per minute. It's easy. My drip factor. Well, I'm giving a drug, so it's probably going to be microtubing, and it is. Concentration, I have 1.8 milligram per ml. So the hardest part about this problem is that my concentration is a decimal. Still the same formula, dose ordered times drip factor over concentration. So my dose ordered, I have 1 times my drip factor, which is 60, because I want to give 1 milligram per minute. Drip factor is 60 drops per ml, divided by 1.8. 1 times 60 is 60, so I got 60 divided by 1.8. So got some long division here. Remember, we're going to move this decimal place over, which means we need to move it over on this side. And that just means we don't have to divide any decimals, which makes our math a lot easier. So 18 goes into 60. So this is where you might have to play some guessing games. I know that 20 goes into 60 3 times, so let's go ahead and just try 3. We do 18 times 3 over here, see what we get. 8 times 3 is 24. 3 times 1 is 3, plus 2 is 5. So that's going to get us pretty close. So I got 6 left over. That looks pretty familiar. So I know it's going to be 3. Oops. I don't know why I put 0. Again, we have a remainder of 6. So we need to add a decimal. And this is going to be a repeater. And we can go, whoa, we can go ahead and stop right there because we only need to find 1 decimal since it's a drip rate. We can't give a fraction of a drop, so we're going to round to the nearest whole number. So 33.3, we're going to end up giving this patient 33 drops per minute of amiodarone. And this is an actual amiodarone dose that we do in the hospital. So if you work as a medic in the ER, this is something that you'll probably be doing because we can give our, 150 over 10 minutes, and after that we switch to a 1 milligram per minute drip for our maintenance infusions.